So today we are studying A level physics. So yeah, we basically are talk about physics chapter CIA CIE. Sorry, I'm making that in that way. A level physics. Oh, I already typed physics. I'm forgetful. Sorry. CIE A level chapter one. Physical quantities and measurements. Physical measurement. Chapter physical quantity and measurement one. So basically we talk about basically physical quantities, which are basically any measurable quantity in physics that has like a magnitude and a unit. For example, time, it has unit seconds, and that's also the magnitude. It's how the magnitude is measured. So yeah, so mainly we like for example, first we have SI based units, which basically means all units of physics anywhere are derived from SI based units. We have time in seconds, time time seconds, time seconds. So yeah, time seconds, which would be S as the SI unit. Then we have mass, which is kilogram, of course, which would be kg, which is common knowledge. I will note down all of them so you can remember them, because they are important to remember. Mass, time seconds, S, mass, kilogram, kg. Mass, kilogram, kg. Time seconds, S, mass, kilogram, kg. Next we have now these two are done. Next we have ampere. We have meter, distance. Sorry, that's distance. So not meter, that's distance. Meter or m. Distance, meter. Now we have next, what's it called. Now we have sorry, I'm kind of forgetting. Avogadro's number of particles. Avogadro's number of particles. Avogadro's number of particles. Avogadro number of particles, which is mole, or which is Avogadro number of particles, moles, which is named moles as moles. And SI unit is mole. Next we have temperature, which is measured in Kelvin. SI unit is K. Next we have luminosity, which is measured in candela or C. Current is measured in amperes, in ampere, and SI unit is A. So we have covered the SI based units. So we'll talk about derived units. Which are derived units? Derived units are for that, SI units, derived units. Derived units basically are gained from gained plus found. Found is more appropriate. Gained from dividing or multiplying base units. That's right. Gained from dividing or multiplying base units, such as force, which is basically mass multiply A, which would be kg, meter, minus 1, which is basically kg multiplied distance over time. So this is basically how we measure questions will appear in exam. Like you will have a certain derived quantity, and you will maybe be asked to find the SI based unit form of it. So that could be a question, but my knowledge is kind of weak in there, so we'll not talk about that right now. So SI base units, force is ma, kg multiplied distance over time. So next we have so let's take a division example. So let's say we have pressure or Pascal. Pressure would be force over area, so Newton minus 3 or Nm meter cube, so that's equals to this. So we have talked about both of them. So next we will talk about homogeneity. Homogeneity might be confusing at first, but it's basically how you measure homogeneity is basically how you measure like the SI base units on one side of the equation equal the SI base units on the other side of the equation. Basically, let's say we have 1/2 mass multiplied by volume square is equal joule. So joule would be let's try to work this up. 1/2 kg meter minus 2 is equal I'm kind of stuck here, sorry. So yeah, basically this will equal this as well. So let's see, we have 10 joules and we have 1 over 4 multiplied by 5 2. So 10 joule here, 10 joule here, so homogeneity is right. Otherwise the laws of physics will be broken. But yeah, I let's talk about you know homogeneity is done. So we will now talk about a scalar and vector quantity. Scalar, and we have already talked about this, so this relates back to scalar and vector quantity. Sorry, I missed a vector. I'm not mindful at all. Scalar and vector quantity. Scalar and vector quantities. Scalar and vector quantities. Sorry, my notification came up. Dismiss. Scalar and vector quantities. Basically, we have scalar only has unit and magnitude, but we mainly talk about magnitude, not to confuse with SI base units and physical quantities. But basically, scalar and vector are physical quantities, but they are more complex form of them. This would be meter, this would be kg, this would be joule, this would be so on and etc. Scalar. Vector would be vector would be something like force, pressure, gravity, which is a type of force. So yeah, so now we have another thing about vectors, which is adding or subtracting vectors. Adding or subtracting vectors. Adding or subtracting vectors. So basically, if we have this vector 5 Newton and this vector needs 3 Newton, we will use Pythagoras theorem and use head to tail rule, Pythagoras, which is already discussed in O level physics. Pythagoras theorem would be 3 Newton square plus 5 Newton square, which would be 9 and 15, 9 plus 15, which will be 24. So we can take the square of this. Sorry, I'm kind of bad at maths, so I will just use the calculator. So it's 4.89 Newton, or like this, or we have another method which is basically similar to this, but it uses a parallelogram method. So the resulting vector will emerge from here. Like this is 5 Newton, this is 4 Newton, and we will again plus them like before, and we will get the answer. So that's basically it for here. So if we have subtracting vector, we will just use the same method but subtract them. Like we have 8 Newton plus 4 Newton, 8 Newton square minus 4 Newton square is equal, like this force is actually not like these are opposing forces that you can think in subtracting, like one is going here, one is going here, 5 Newton 4 neuron and 8 neuron. So we have 64 neuron minus 16 neuron, which is 48. Sorry, I am so bad in maths, I kind of am in a very unproductive environment, so I kind of want to rush this. I'm really sorry about that. It would be 6.9 neuron. So yeah, next we have resolving vectors, which is a bit more complex, but it's graspable. You can understand it. Resolving vectors. So yeah, for vertical vectors, we have cos, like this is like, let's say 35 degrees and 10 newton. So we'll write cos 10 newton 35 degrees into the calculator to get the answer. Otherwise we will use sin, and it will be like from here, like clockwise or anti-clockwise. Like if it's vertical, it will be clockwise, otherwise it's anti-clockwise, like here. So let's say this is of course 55 degrees, 55 degrees sin 10 newton 55 degrees. Here cos sin 9 newton. So yeah, let's actually calculate them in the calculator. Cos 35. Oh, I am actually so stupid, oh my god. I should have, sorry, I'm really bad at maths, but I'm improving slowly. So this would be actually 35, 10 newton, and same here. So let's erase this. And let's now enter it. Oh. I'm so sorry, I don't really I will kind of debug this. Like this is actually a test run, so I could change this. Resolving vectors. Next we have measurements. So measurements is like the last part of this. Measurements, or oh my god. So I will also make flashcards for this revision. Measurements. Now measurements basically have some problems with them. We have like different tools, but first we will talk about errors, which would be random errors, which cannot be controlled by us and are caused by the random fluctuations of random of either human reaction time or some uncontrollable variable in an experiment. Random errors. So we have that. Random errors. which will be for the human reaction time. I will just note it down so both you and I remember this. Human reaction time error. Human reaction time error. Random error, human reaction time error, uncontrollable, sorry, my writing is awful. I am in a very unproductive environment, as I already mentioned. Uncontrollable variables such as environment temperature. Environment temp. So we have now systematic errors, which are caused by errors in the equipment, like you maybe like the stopwatch might be broken and it might not count the first second or the second second, and then it will be like error in equipment. Next we have zero error, which is already deeply discussed in the first chapter of O levels. Zero errors, which is basically like you have this scale here like a ruler. So basically 0 and 1, you basically, instead of directly viewing this, you view it like this, which is wrong. So you view it like right like this. So that the zero this is the parallax error, but it is a type of zero error. We also might have a bit of wear and tear at the board, like at the 0 and the 1 place, so we might not read it properly. So that's the zero error. Or if we have a vernier caliper or a micro screw gauge, we might have it might not be properly set up, so you might read it wrong, and then thus that causes a zero error. Now we have next uncertain. No, first we will talk about accuracy. Accuracy. And accuracy is basically being near to the true value, or is like we have the true value is 10 Newton, so 9.9 Newton would be accurate but not precise. Precise would be a number of values being close to each other. I might be wrong about this, so you might have to check this out. So I myself am a student that's just beginning out. Precise, a bunch of values like 9.9, 9.8 that are close to each other, 9.999 or 9.81. So these are all precise. Next we will talk about uncertainty in calculations. Uncertainty in calculations would be uncertainty in calculations. So uncertainty would be like we have percentage, and uncertainty is basically like some type of uncontrollable value, like you would not get the true value but close to it. Like we have like 10 Newton, so plus 0.1 minus, like you can have 9.9 or 9.9 or 10.1 Newton. So that's uncertainty. Uncertainty can be in percentage, fraction, or absolute. So percentage would be calculated basically like a percentage, 10 Newton, let's say, and then we have, not like that. Oh, sorry, 10.1 Newton. Newton multiplied by 100. So basically what the value comes here is basically the percentage. Uncertainty fraction would be calculated, of course, in fractions. Absolute would be, basically the amount of uncertainty that you can will always have, like that's already pre-confirmed by other people. So let's say we have 5 Newton. Basically, let's say we are measuring acceleration. So let's say we have 5 seconds plus 0.1 or minus 0.1. Next we have meter, which is 10 meters, 0.2 plus minus. Next that is meter, and sorry, I was getting a call. I will just check it in a minute, but let's first continue. First we have these two. So let's say that's 5 meter. So it traveled across, like, let's just do speed. This is a bit confusing for me. I am a new but just like you guys. Distance, time. So let's say, so we'll calculate the percentage of uncertainty here. Let's say it's 5.1. Do I have 5 point? पढ़ रहा हूँ, 2 मिनट सब्र कर लो, आ रहा हूँ 2 मिनट. So yeah, we get 98% uncertainty if we divide like this. So 98% accuracy, so it's 2% uncertainty. Uncertainty. So time will be that's the Bohr's time. So for meter we will have 10.2 divided by 10. Oh, it's similar, so use 0.1 second, 2% again. So this will add up to 4% in speed uncertainty. That's how you add them. I might be a bit wrong, so we will talk about this later.